Welcome back to our Scala to Spark class, and we are continuing on our day 11. We are continuing to work with NoSQL databases. In particular, we are learning about key value stores, of which again the most popular is Redis. So the interesting thing is that technically, well, Redis claims it's not a plain key value store, right? Well, as we saw already before in yesterday's lecture and today, there are some other structures. But of course, the main basic idea was behind Redis when it came out was these key value stores, just basically keys on which point to some values. But today we will look at some more of these structures, right? So binary safe strings, lists, sets, those are we have covered. We look at some of more complex data structures which you can use in Redis. So sorted sets, hashes. So this is something similar to map. Right? This is of course sets. Bit arrays, it's meaning just you can have individual bits. You can manipulate individual bits, and there's some interesting rare structures, hyperlog logs, probabilistic data structure, right? Very interesting. Looks scary, right? And also stream type of structure, which is of course when you have data that's coming in as a stream, right? Okay, so of course it's again usually most of the major things are covered by these binary safe strings, and maybe sometimes lists are the bread and butter, but we'll look at these deeper ones again. So Redis keys are binary safe. It means anything, any type of information can be a key, right? So anything like a foo or any strings, right? Or a whole content of JPEG file could be a valid key, right? An empty string also is a valid key. But as they warn you, very long keys are not a good idea, right? So to 1 kilobyte or 1024 bytes, that's pretty big. Again, it will affect the manipulation of database. Also, on a reverse, really tiny, something indescriptive, something like U1000 FLW, right? That's only useful for somebody who is writing this, right? But in a couple of weeks, you will forget what that means, right? So you should probably write something like this. Again, this is what Redis recommends. That's why we see these colons. Again, the colons have no special meaning. It's just a way of separating these levels of data, basically, of your key, right? Make it more readable, basically, right? Again, so again, the balance, it's always a work with balance, right? So they say try to stick with a schema. Well, we don't really have a hard-coded schema, right? So they say stick with one. This is fine, of course, you can use this, right? But again, be consistent, right? Again, of course, if you work with somebody else's database, then you will use whatever they use, right? Maybe you will just reading it, right? So we already saw this is the basics, right? Set and get. We can set and get on. So on also again, remember set replaces everything, right? Even if it exists, right? And values, right, can be strings of any kind, including binary strings, meaning it could be even a JPEG, right? But limitation is half a gigabyte, which is pretty big, right? So, for example, you can ask to set to fail if the key exists, or reverse, succeed if the key exists. So overwrite, so guarantee overwriting, or extra option. So this is my key, my new value, and this option says to fail if the key doesn't exist, and this actually says succeed if the key exists, right? So set, we already saw increment, you played already, this is increment by, right? So parse the string, again, it parses the string value as integer, increments by 1, and then sets the obtained value. Will we see? Again, we talked about this atomic, that's we already saw previously, right? And also there are mset and mget commands, meaning you can set multiple key values at once, right? Because why would you want to do this? Because of course it's going to be faster, less latency, because if the database is somewhere in the cloud, well, you want to save some time. You make multiple queries. Again, this is, as you saw it also with SQL databases, bunching requests together. That's how you save time. Of course, right? If you want multiple commands, then this is something you want to get, mset, mget. Let's see if mset and mget is in our client. I believe it is, if I remember correctly. So let's do a new class, new Scala class, day 11, Redis, the more command, or intermediate, called intermediate, right? Something like that. Of course, object, right? And extends app. And let's see, do I have my database? I have not checked. I hope I still have my database working. So I'll just copy, of course, these things, right? I need my connection, right? My port, and you, of course, have your own, right? So I will use this. Incidentally, I could say the port as well, right? So this will be more deeper look into Redis commands, right? On operations on. So port, we want URL again. It only works, remember, this only works because I have saved in my environment. This works, remember, this works because this host is in my system environment, right? In the system environment, I have it here, right? We saw it, it's somewhere here, right? Redis, right? Similarly host, and there's my password as well. Again, obviously you shouldn't share your password with everybody, but again, if it's in your computer, right, that's computer you control, right? Okay, so, and that's my host name as well. Okay, so I'm loading up the password, of course, right? On Scala utilities, properties, environment or else, right? Or we can use emit or none. We can do also, can we get none? But it will give you, if you get anything, I can do this as well, right? Let's do that maybe. No password, we'll get nothing, right? So what's a string? We can try that. Because of course this it would help nobody, right? This default value would help nobody, right? So, but only thing is, what's interesting, we have to wrap it in some, right? The password, why do we have to wrap it in some? The password has to be wrapped in some because that's what the client, what the library requires, right? So let's see this, right? So Redis password, I want environment or none, meaning I get nothing. I don't want, I mean, this is kind of, not needed, right? Because it's not going to help anybody, right? So some, right? So option A, right? Or else, right? Well, this is of course a string, so that's the difference. Here you don't know what you're getting, right? You're getting some. Well, notice something here. Some. Oh no, everything's fine. No, it's fine. Sign option string. Okay, that's good. Okay, so some option string. Let's see, and this is some string. Well, maybe this is not as good because it gives you option string and this gives you string, right? So we probably still have to get. We still have to get else, right? We need to provide else, I'll just provide a blank, and this is of course better. Yes, we have some string. Okay, again, so that's again, why is this problem with some? Because, well, it's not Scala specific. In most other language you have to deal with somehow else. You have to write some if statements to check, okay, is this actually existing, right? And you have to write more code. Actually, this is in a way shorter. It's not that horrible because it's the issue of dealing with non-existing information, right? Do you have anything coming in here or not? You have to figure out some logic to deal with it. But okay, so we'll make a connection as before. We can make a connection on, right? You can just, R of course is arbitrary. And the only thing that's interesting is here, we didn't talk about this too much, but no, cancel, right? Of course I don't have a client, I need to import it, right? I need to import it, okay, and we're good, right? Com Redis to this client, we have client, and we should be good. Let's run it. It will fail or not, we'll see this, of course, the logging problem, because we don't have setup logger, but again, that's a good thing Ali talked about, because there is a issue with the logging, right? So this is so logging is not, nope means there's nothing happening, right? So it's not logging any information, right? So looks like connection worked, so we can start working, right? So we can start working with mget and mset. I already forgot what we have. Let's see if we can get what happens. We have my name and we have my count. Okay, we have at least two values. Let's try it. So values, right? My values, right, will be what? R, M, yes, we have it. Okay, so how do you do it? Keys, okay, so looks at this, it's keys any's, right? So let's try it. So I will do my name and what else is my I forget now. My count, and what else do we have? And number. Okay, my count and number. Okay, I have three keys. Let's try it. Number. Okay, this is legal. So notice how it works. The first key, again, it's very common in this signature for this method, mget method. The first one is singular, right? And afterwards, you don't know how many. Maybe you have 10, maybe you have 15. Well, it's possible, right? It says it goes under single keys, right? So key and keys any, right? And then it basically, and it returns option of list of option. Again, you'll have option list of option anything, right? Because anything could happen, right? So we will want to transform this into something, some values, right? So okay, we have my values, right? And again, let's do get or else, right? Get or else, right? And right, list option string, that's a type, list option string, right? And let's do that, get or else list option, and I forget string, right? Kind of silly, but yeah, on this blank, right? And this is list option string. Great. So we either get again, so we cast we either get a list of option strings, string options, string options, or we get a blank list of string options, right? I'm saying, okay, this is, notice here, right? This is a blank. This is basically blank list. Again, list, again, that's what the library requires. Again, because, well, array would be just fine. Of course, now, if you have a list, right? Of course, if you don't like it, I mean, if you don't like it to array, I can do this. I mean, it's not okay, right? This is going to be an array of values, array of options of strings, right? It's fine. Again, there's not that much difference between list and array. Again, array is more compact, right? For me, you can do this, right? And of course, I can do the regular stuff, right? And now, again, my values, and again, this is what will have option string. So this will print this. Let's see, for value, my values, right? And since these are strings, values, right? And or v, I could do v, right? Let's not so. And basically print line, and let's do this s and the value, right? Again, value will be value get or else, right? And I'll do just blank string, right? That should do it, right? Let's see. So what do we expect to see, right? Now let's see. Any errors? Yeah, so value Valdez, value 21, value minus 32. Right. The only thing, of course, that you don't like, you don't know the keys, right? This is just a value. This gets multiple values, right? This gets you multiple values. Well, the keys you have to figure out yourself, because these are you provided by yourself. Of course, this is just these are just the values. Associate the keys yourself. Yeah, right. So you could do a tuple or do something else, possibly, right? But you would get again. So the only thing I think is a little bit messy is this option, personally, right? Because you have to keep getting get or else. Because theoretically, right? Let's do one more, right? Let's do bad key, not bad key, right? What will happen? Let's see if it'll affect anything. Bad key, right? Let's try this. It shouldn't break, but let's see. Yeah, so actually that's very interesting, right? So what happened? First of all, our query worked fine. I mean, so this empty list didn't work. I mean, our database works, right? So obviously we got something, but again, we had to be ready to get nothing, so that's why I had to provide this. But so in our list we have 4 values, but the third one, right? Well, this bad key, right? The value was it was nil, right? It is non-existent, so I got the blank default string, right? So notice that here, right? Okay, so similarly, let's try our okay, no, sorry about that. So let's try setting up, right? So set multiple values at once. Okay, let's try this. So let's see what we get. So rm set on. Let's see how it works. Any, right? Key value pairs. Okay, looks like, so look at this here. Key value store, key values, any, so anything goes, right? So it could be let's say whether, let's try this tuples. So it should be like this. Let me see if I got it correctly. Whether sunny, right? Sunny, that should be enough, right? Is this enough? Yeah, that's enough, right? That's single, right? Well, it is sunny right now. Let's see, let's do one more. Let's do what can we do? Temperature B. Let's try this one. It's allowed. Let's say 30-25, right? Again, any. So it's very loose, right? So let's do one more. And let's do what else could we do? Let's see. Again, some example, something berries, strawberries. I don't know. Berries, strawberries, right? Okay. Strawberries. Right. Again, so there are no restrictions. So no restrictions on this. Notice no restrictions. Notice no restrictions on values, right? I could do any because that's what it says. So that's how you read it. So this little star implies, well, it says you can do as many of these you want, right? It's going to be unrolled, right? And you are able to do as many of these pairs as what you want. Again, anything could be a key technically, right? We could try numbers, but again, technically you want something, you know, some of these. So these, you start using colon syntax, right? I could do one more, right? I could do favorite berry, right? Favorites. Maybe do this favorites, right? Berry, strawberries, right? So this would be a good one, right? Favorites, strawberry, right? Again, it's just an extra way of separating. If you have you need to put some structure. Again, it's up to you. Well, whoever is doing this data, saving data, to figure out some structure. Again, again, you need to figure out some way of adding this structure to this database. Okay, let's run it. Now, of course, I do this afterwards, right? So we don't expect to see anything. Do we get anything? Results, mset results. What do we get? Do we get anything back? I think we probably get Boolean. Oh, it just basically it worked, right? So it worked. So I assume let's do this. Print line mset worked. If it's Boolean, so mset results, right? So this basically is a Boolean, right? Nothing interesting, right? Mset results. Okay, let's run it. Maybe I made a mistake somewhere here. Maybe it's not allowed, but I think it's okay. But let's see. Yeah, mset worked. Okay, so we have this 3132, right? Nothing else is happening. So I expect these 1, 2, 3 new values. Next time I run my database, access it, I will get these values here, and of course I'm going to also override them here with the same values, right? Of course, database is optimized, Redis is optimized to not do anything if you're trying to override something which already exists, right? So this is normal pattern to do to something, overwrite something which you already worked on. So let's run it. Ah, mset worked, yes, but you only get, so this didn't work. Huh, very interesting. Weather, sunny, it looks okay. It looks okay, but we didn't get it. What happened? Where is it? It didn't work, right? Very interesting. This mset doesn't seem like, let's look at the, I'm not getting it. So, because of course, if I put something here, right, r set, let's say, computer type, right, Lenovo, right, this should, we should have it, right, key value, right, the basic one, right, this should work. Let's see what's happening here under the hood. Maybe there's some caching issue. What's going on? Right, oh no, everything's fine, right, oh no, everything's fine, but of course we are not getting the other ones, right, everything's fine. Okay, so I'm just imagining, so remember we had to get everything, right, you get keys, right, we can also get values. Let's try getting all the values out, right, if we get all the keys, right, what's possible, right, so we could print all the keys, right. This was keys list some string. Okay, keys list option string, right? So we would, let's get all the present keys, right? So everything works, right? I was getting mget, of course. I'm getting only particular ones, right? So I should be able to get weather, right? Or favorites berry, right? Favorites berry should work, right? Favorites berry, of course. I should have berry is not a good word, but okay, berries, right? So berry, so I will run it. Yeah, value strawberry, it works, but of course if I do now, the way it should be singular, berry and berry, right? So first time I run it, it will be empty, right? Because I don't have it I set up afterwards, right? But now once I run it, of course I will have it. So value is nothing, but if I run second time, of course I will get it, right? Yeah, so now strawberries. And again, so if I did this, control cancel, right? So keys, I can get all the keys. Again, reminder, you can get all the keys from day 10, right? This will work just fine. Again, lots. Again, that's not too hard to work if you need to do. Right, I'll show you that this actually I do have all the keys here. Right, look at this. All of the keys are present, right? Well, of course, class sum, right? So of course a key, right? And it's just sum, right? Because of course we would probably want to do map, right? Let's do mapping. Maybe let's do map. Let's do map, right? And we'll do this. Can we do this? Yeah, get or else on, right? Something like this. So what happens now? We should get rid of all of these, right? Right. We map everything, and we map. We go through the whole list, and we map all this sum to get or else. You know, it's a string, so get the blank string. If you have no. Obviously it's gonna be it's all present here, right? It's not this is basically just extra work, right, on top of it, but again you need to wrap it, so in case sometimes you wouldn't get, it's possible you don't get an answer. And now of course we'll see that, yeah, key my count is string, right? It's my name, and so on, right? And we can get, so friends, favorites, berry, superpower, this is all stuff we did yesterday. It's all present in this cloud database. Excellent. Okay, so we got multiple set, multiple get, right? What else was there? Again, set exists. We saw this. We can delete keys, of course. We can clean up, right? And can we check the key? You can also do commands. You can remember time to live. We checked. Remember that. So, right. Right. The array. So list is just so the type of lists is it's mostly so Redis lists are they are actually close to Scala lists in the way that they are, you can do very quick performance. Lists are linked lists. So what does it mean? What's a linked list, right? We saw this linked list, right? It's a fundamental data structure, right? And you have every item has a reference to next item. Usually you have double linked lists. It's usually, where is it? Here, like this, right? Doubly linked list, right? This is the main article, right? It's one of the fundamental structures in computer science. And you start somewhere, right? Each item has a reference to the next item, also reference to previous item, and of course at some point you stop, right? You have some blank special sentinel or special items which are holding end and beginning, right? So what does it mean? This means that you can do this very quick insertion and deletion at the beginning and at the end, right? So that's what this data structure is, right? Again, but what's the bad news about this list? That's why lists are very good in small amounts, or they are very good if you need to insert many elements in beginning and top. You don't have to move a memory, right? You can just keep adding these references. But the bad news is, of course, is that lists are quite limited. They're not as popular as older days, right? As they still have some room, but arrays are just one big chunk of memory, right? Lists are, well, not continuous, right? You have to keep jumping back and forth in memory, right? You hold some items, right? So it's a little bit extra work, right? So you can't go to item, if you want to go to item 367, you can't just jump, you don't have a reference, you need to go forward, right? So it's a very slow process. So lists are good if you need to add something on top and in beginning and at the end, but afterwards you might want to go back to an array, right, or vector array type of structure, right? So that's what a list is also in Redis, right? So accessing a array, right? So that's downside. Indexing by index, right? So L push or right push or left push, it's going to be extremely fast. Everything's great as long as you don't need access the middle somewhere, right? So you want to add, so these lists are for insertion, I mean for adding elements, it's going to be very fast, beginning at end, right? But also middle, right? There will be sorted sets, there will be some other items, right? We only saw L push, R push, right, and R range, right, to get the items out. Okay, so when would you want to use it, right? You have some new updates, right? By users in social network, you would save them, push them into this list, right? So somebody adds some items for consuming, and somebody else, some other program reads them, right? So Redis is a place to store this information, basically, right? So Twitter, the Twitter, by the way, is using, at least I know it used to be, I don't know if it's now, but it's used Redis for caching these latest tweets, right? Because even if you have billions of tweets, you can still add new tweets, right? Because this information, you don't have to add, you don't have to move memory. You just keep adding, right? You have reference. I mean, that's the beauty of the, again, if you have a special need, right? You can keep adding. You basically add new element and move this end to the next element on reference to this element, right? So similarly, if you want to delete this, right, you get rid of this and you move this arrow to the end element, right? This arrow here. It's very quick, right? But again, like I said, nothing in life is free, so you can't going in the middle of something, right? Well, it will take time, right? Of course, right? So you can trim, right? Also, there's some extra commands, right? You'll have to look up. So let's look at maybe blocking. We'll wait for that. But what else? We do key expression lists, hashes, right? That's the one we want to talk about today, right? Is the hashing, right? So field value pairs, right? Right, this anti-res is the creator of Redis, by the way, that's his nickname, right? So HM set, right? So we can get field value, right? So hash is user 1000, right? And these are the fields, right? So it's like an object. Think of it like an object. So object user 1000, and they have values. So something very similar, right? So if you had in a database, again, if you store in a Redis database, you store this user, right? You would then want to read it out. So let's see how it works in Scala, right? So we're gonna do hm_set, right? Right, I will do this here. Let's set some. So rhm. Let's see, how was it? hm_set, is it? Yes. Okay. So now, okay, we'll do user. Let's say Valdis or user. Let's say 100, or I don't know, user 42, right? Doesn't matter. And now we need iterable, right? We need any, right? So we need any type of iterable, right? So that's a format. So anything, could be a list, could be an array, it could be a vector, it could be anything, as long as it has to be iterable, right? So let's do array. I'll do array. It should work, right? And the type product 2. That's the only thing that's interesting. It wants any map, right? It has to be. Let's see if I got it correctly. Mapping, right? Let's see if I can do this. Can I try this? I don't know. Name Valdis, right? Let's see. This is enough. Okay, array string. Okay, and not what we want. Doesn't look good. So we need. I think we need tuples. Yeah, I think we need tuples. Yeah, one more. Yeah, okay, that's legal, right? So I can add more, right? I could name likes. You know. Let's see. Likes potatoes and so on, right? Yeah, okay, still legal, right? So that's this is the hash, right? Just like this, and these are gonna be the fields, and these are gonna be the field values, right? And let's see. So you can store objects all into this type of structure, right? And let's do one more. Let's do maybe something like I don't know what else, right? Likes, and you know, what something color green. I don't know, green. I don't know, right? So this should work, right? And let's see about getting the values out, right? So we set key to we set key user 42, right? It will have a hash fields, name, likes, color, right, with corresponding values, right? So green potatoes I don't like, right? But so let's see. So let's read this. So question, of course, now, okay, we set it. So age get all, right? This will get you all, right? Let's see. It has no practical limits, right? So this is a very generic way, right? So we can get these. There's get and there's get all, I believe, right? So let's get. Let's do age get. So name, my name will be what? So rh get, right? Key field. Okay, so I need key user 42, right? And field will be name, right? There should be option. Oh, it's option. Okay, get or else, right? Get or else, of course. Again, sorry, again, extra work, but you know, a little bit messy, right? And we can print. My name is print line. My name is my name. All right. So this gets you. Let's run it. My name is Valdis. Okay, everything works, right? So age get works. Okay, now how do we get everything, right? You want to get age all. You want to get everything. Get all, right? right? And we can also, all right, actually, yeah, we didn't check, we can do increment, right? So let's do something, let's say let's do one more here. We can do, let's say, again, I'll do comma, right? So we can see this here, and I'll do something like, and like potatoes, let's say, parking tickets, parking tickets, right? And I'll do 3, right? For now, right? So this sets, right? This, of course, this is set operation, right? So if I get my parking tickets, right? Hopefully I don't have any actually, but well, let's go with it, right? So well, parking tickets, right? It will be, of course, get keys, user 42, and field, of course, is parking tickets, right? Parking tickets, right? And of course, it's again get or else option string. So what we want to do is get or else, right? And I'll do maybe 0, right, as default, and to int, right? To int, right? Because of course I expect to have int, right? Right. So it should work. Let's see. Print line. I got my name. Got tickets. Okay, something like this. Let's see. Right. So let's see what happens if it works. Yeah, well, this has got 3 parking tickets. Okay, everything works perfectly. Okay, so they mention here you can do age increment by or age increment, right? So age increment by, right, something like this. To look this hash commands, we can check it out, right? So age delete, age increment. Is there single increment? No, I think no. You can do this age increment by, right? You can also do float as well, by the way, right? So age, you can also check if there's some key, if some field exists in your. So again, as you go on, so again in the hash you can think of it. So hash refers to an object with multiple fields, right? So it's a way of, well, doing some more structure. So let's do increase one ticket count. So what is the name of it? Age increment by, right? Yes, increment by. So all the commands are supported, right? So we need the key. So it's going to be user 42, right? We need the field, parking tickets, right? And let's increment by 10. Okay, I guess somebody has been driving around Riga and not paying attention, right? Bad. Of course, do -1, -3. So, of course, again, this is value, right? So I'll do var. I'm lazy, right? I'll do var, right? So I will do this again. Lazy, and right, and I should have 13 parking tickets, right? Expectedly I should see 13, and so on and so on and so on, right? So again, nothing too crazy. Again, I mean, it's just a little bit of language. Yeah, I have 13 parking tickets. Okay, everything works. Of course, if I run it again, so how many tickets will I have if I run it again? Well, will I have 23? Think about it. What am I doing here? Thing is, I'm setting it here, right, to 3. So I'll have it again, 13. Why? Because I always overwrite. So I currently have 13, right? This is our last case, right? But if I run it, I access my database again, I'm gonna reset it here, right? I'm always setting up the tickets here, right? So whatever value I put here, this will be the value at the moment I run it. Okay, so you see, it still stays. So again, if I use set, right, it's going to overwrite the previous value. If I do increment, it will add this value. So one last thing, if I want to check, let's see, we are running out of, well, we have some time. Do you have any other commands you want to check? So sets we checked. Again, let's use the sorted sets, right? It's like a mix between set and hash, right? They're sorted, right? They're not ordered, right? But they have a value with a score, right? They're not ordered directly, right? Right. So you can add a score basically, right? Like a movie score, right? You can add score. So it's like a add, but you add an extra. You have a score to your set basically, right? And you will be able to compare them, right? Go by dates, I believe, right? So these are the birth dates, right? Let's try this example, right? So very interesting data set. So sorted sets, and again, I think there's multi-add again. Let's see, do we have commands? Let's check. I think there's multi-add as well, right? Right. So they're sorted by a score in ascending way, right? So we'll have to we'll be able to access it. Do we have any more commands? Yeah, there is. Look at the OZ commands, right? So there's many commands. Again, it's you are not expected to. Again, you only use what you need. Again, but there are many commands. Again, so again, originally there were not that many scores. So you can, again, they mentioned about the floating point issue, right? The scores, right? So, but again, we'll use integers values for now, right? So we will. It was not originally present, right? So and again, it's not instant, it's log n. It takes some time to add this, right? Set operations were faster and the key. So this is a little bit slower. If you need something like this, right? Well, then you have this option of doing it. So let's try adding some of these people, right? So this is a command line option, right? So we'll have to implement this in Scala, right? So this part here, let's see here, sorted sets, link. Right, okay, oh no, sorry, where's my link? Copy link address. Yeah, there we go. Okay, so R Z, right? Add. So this will be key. What's going to be? What kind of key they use? Hackers. Okay, let them be hackers, right? Why not? Let's call it hackers, right? And so score and member, right? And score value. So you can keep going, right? Score values, double any. You could keep going. Score values, right? So let's see, hackers. So we'll go Alan Key, one of the famous programmers, right? So we'll do this, right? Yeah, okay. Is this legal? Yes, this should be no. Okay. Score member, right? So can you do more? I think you can do more, but I'll do some few more. We'll do Sophie Wilson. So I assume these are right. These are again, all of these are programmers. Well, not only programmers, you know, basically English scientists, inventors, right? So score Wilson, right? And let's do one more, right? So we have 3. Claude Shannon, very famous, well, Linus Torvalds, all of these are famous guys. So we'll do Alan Turing, of course, we'll add him, right? And so RZ add, right? And we'll do this, right? Okay, so key. Right, and it's hackers. Right, so it's single key, right? And you have score, right? You add them by score. Okay, right. So it's like a set, but again, so hackers refers to this sorted set, and the values are inside, right? And they have a associated score, right? Okay, we have 3 values. Let's do one more. Linus Torvalds, let's do him, all right? And then we should be able to see some. Again, of course, key is arbitrary, of course, but it's all. If you change somewhere here, of course, it will refer to different item, different value set of values. Okay, so Z stands for sorted sets, right? These are sorted set operations, right? So, okay, and we want to get this, right? So what happens if I do get, right? Well. I think you need to do Z get, right? So how do you read it? Z range. Let's do Z range. Right, but we don't have to do any extra work. Redis already has sorted. So 0 to -1, right? So -1 means last element, right? So let's do that. All hackers. well, hackers will be what? R, Z, range, I believe Z range, yeah, Z range, on we need key, right, key, of course hackers, right, on 0 and -1, okay, and what do we get? Probably, I'm assuming this is going to be a list of options, right, option list string, yes, of course, so what do we do, what do you think? Get or else, and we get list option string, right, and again I'm gonna do this here, right, okay, one more parenthesis, no, everything's fine, let's see, so this is now working, list, sorry, oh, did I make a mistake here, list option, maybe I made a mistake, there's a mistake somewhere here, the range, if I quit it, it is what? Option list string, and how did I, oh, option list, sorry, oh, list, option list, option, oh, here, like this, yeah, this will be correct, oh, one missing, finally, I hope I'm doing it correctly, yeah, this should fine, this will be fine, what's the problem here, this looks okay, oh, there's comma, there's a stray comma, sorry about that, okay, that's why it's looking weird, okay, now we should be fine, list of strings, this is fine, so print line, and what can we get scores, that's a good question, right, so hackers for each print line, right, or we can do basically this, right, print line hackers, make string, right, that should work, let's try this, so it should be what, Alan Turing, Alan Key, Sophie Wilson, Linus Torvalds, right, I hope so, it works, yes, so Alan Turing first, Alan Key 1940, right, second, Sophie Wilson third, and Linus Torvalds is the fourth. Okay, great. So we saw how sorted set works. Again, there's some more commands operating on ranges, right? Some more. Again, you can make it more complex too, right? You can operate on these ranges, right? You can do Z range by score, right? So you can do these type of queries. You can see all the people who are born before 1950, right? So again, of course. So the question again, at some point if you make it too complex, then again I think at some point you want to go back to SQL, right? But it is possible to make some pretty interesting things again, even including Redis, right? So you can do like check all of those who are infinity to 1950, right? Minus infinity, and that's a good question. How do we do this by do it in Scala. Probably need to do some infinity, right? We had some, so that's something to do. Maybe this will be your exercise. Scala negative infinity. Remember how we did this, right? It was, I believe it should work. This should work, right? And final value. So any double negative infinity, I think you could do this like this, right? We can of course we can do any negative numbers, right? So okay, so let's do well, I'll do a little task separately in a moment for you, right? So we saw today a little deeper look into hashes. We saw also sets and list operations, and also we saw the sorted set operations. All right, so we'll have a little exercise next. Thank you.